Carlos and John, and we came to see what we had in all these boxes and we spent a year getting here. And we tried to make sense of them all the boxes downstairs, and most of it seemed to be good equipment and what we needed. But then looking up here, the original plan had been to put this battery system all the way down there. But that was a really long run for these cables, so we figured we'd need to bring the batteries closer to the panels, because running 12 volts, and I don't know how much you guys all know about solar, but if you run a 12 volt cable from these panels all the way down to there, it needs to be one of the thickest cables you can get, like a number 2 cable.
So we would spend as much on cables as we spend on panels.
Yeah. So the solution was to build this beautiful body with all the rebar sticking up underneath it. And this is going to be the solar cabinet for the future battery bank as well. I think Pat actually wanted to use this as a storeroom for something else, but I don't think that's really a possibility now, especially if we get another battery bank in. Yeah, they did a great job on that. The only thing missing is some gates to hold it.
That's great. Greg's going to tell us about the project this week, and then Carlos is going to tell us about the electronics.
First of all, thanks everybody for coming. I know Mary Jane and I have been looking forward to this for 2 years. Although there was a screw up in the beginning, and I think Charlie touched on it, we went to Costa Rica bird watching instead. We were like, no way we're going to go down to Costa Rica for a week and just sit around doing nothing. We had to get our hands dirty. So when John said, let's go and actually do it, the panels are there at school, we jumped on it. So we assumed mistakenly by reading the manifest that all the parts were shipped down and we were just going to come down and put it together and button it all up. Well, I'm sure a lot of you realized, some of you, much to your deep dismay, that the tracks that were supposed to mount the panels came without any mounting hardware. And so that led to a day of debate and discussion about how to mount the panels. So we abandoned these very nice, expensive aluminum mounting rails and started coming up with a plan for a bracket that we could support the panels. Of course, whenever you get a bunch of people from Ann Arbor together, it gets totally screwed up. We had some rather unorthodox and highly complicated solutions to a rather simple problem. So after going around and around and around, and I'd say probably 6 or 8 convolutions later, we decided just to fix the damn things. We had swiveling, pivoting, threaded rods moving all over the place, and we abandoned that. And like a bunch of good scavengers, we took what we had and we modified it and came up with this. We took the stupid brackets, which for some reason we only needed like 12 or 16 in the beginning. They sent us 72 of them.
they made up for the part.
72 of them
right.
at $800 for those little feet.
Oh my God.
And we used, well, you count them, 4 per panel, 16 of them. So
we're ready for the next one.
We're ready for the next one.
Yeah, keep the aluminum channel.
We are.
Ben, with Luis, who's over there with those young muchachos, took over the welding and metal fabricating part of the project. And we calculated the size of brackets that we needed. So we took these existing brackets and we made some elbows. And John volunteered to drill all the holes in them. And
so I did something on the project.
He tried to get a couple of them on center.
At least a few were on center.
So they fabricated these brackets, the little curved things that go on the bottom, and Ben and Luis made this framework that goes around here that supports these panels. Even the framework here is over-engineered, but why not? We almost had enough material.
Hurricanes.
Hurricanes, yes, exactly. There's global warming. So we had to overcome a few technical problems. There's one problem called dielectric reaction, and that's where dissimilar metals, when they touch, one metal tends to corrode and give up its electrons to the other metal. And to come up with a solution for that, we went to the classic drywall bucket. And we cut it up with gigantic scissors.
Thank you, Tim.
And Tim spent a day making plastic bucket washers.
Dielectric spacers.
Dielectric spacers to keep the aluminum panels from touching the ferrous metal on the frame and corroding. So we calculated the height of the panels from front to back so we get the right pitch, and we did that about 20 times, and we finally ended up with about 23.5 degrees here and about 26.5-ish back here.
Oh, Doug's gonna be so happy. He's gonna be very happy.
Doug, the solar architect who calculated the orientation of the panels themselves, what we did is we decided to take one bank of panels and orient it approximately 5 degrees off of due south to pick up the majority of the daytime sun, lower angle. We had to contend with the cloudiness during the rainy season, which in the afternoon clouds this whole place over. So, but in the morning, when the sun comes up, it's bright and clear. So, but the sun is coming up over there and crossing over here. So we oriented this bank of panels 15 degrees off of due south with a little steeper angle. So we're trying to optimize and catch the best of both worlds, mostly concentrating on the morning sun that's available, optimizing that because of the clouding over in the afternoon. On these full, clear, sunny days like this, even an idiot could orient these panels. You could point them north and they would still charge the batteries. So we weren't really worried about that. So then we had to come up with a plan for mounting the panels to the deck here, the floor deck. And the source of supplies and materials around here, as you can probably guess, is haphazard at best. I think we've probably been to 8 little ferreterias or hardware stores, and with limited success gotten a limited amount of fastening hardware to complete the project. So we had to make do where we could, or where we had to, in order to get them mounted. So it's kind of a hodgepodge. It's a little bit of mountain engineering. We decided to mount these wooden plates down to the concrete deck with epoxy bolts that are drilled into the roof,
or through the roof,
which also happens to be the ceiling of the room below. And so one of these bolts misses a fluorescent light down there by about 1/4 of an inch.
Oh,
Someone said, "Oh, this roof is 10 inches thick." Well, don't believe it when anybody says it's 10 inches. It's not. It's really only 4. So we bolted them in and epoxied them in. That was probably day 3. We finally had the wooden planks bolted down to the deck. So from there it kind of flew. We actually were able to build the frames and set up production, drill all the holes, put the little spacer washers, mount the panels in their frames. We put all the brackets on the bottom first and let the Backs of the panels hang down. We calculated the heights. We had Luis and Ben make these little stanchions in the back. Just lifted up the panel, bolted them in, done. We went down, boom, 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 boom. And we had one day where we were just like, screw it, we got to get these panels installed. We can't drag this out another day, so a bunch of us stayed up here till like 6:30 or 7 and got all the panels fixed in place. So then the next day, we had to start running all the conduit, which is around here. And you'll see there's a conduit that runs all the way around the parapet, hangs off the side of the building, goes all the way down to the computer laboratory. That supplies the 110 volt circuit for the computers to run off. Then we've got these conduits running across the floor deck, and that carries the conductor cables, which you'll see this little mess in here. They sent us the wrong cables, and so we had to jury rig something, and MJ had to make an emergency run over to Pana last night to get these terminal blocks for us to plug all these cables in. We had to run grounding wire, which brings me to the bravest soul of the group. And we have photographs which will be available later
on our website.
$5 a piece for 8x10 glossies. Well, we have to have a little bit of income to support John's hobbies. Ben went over the edge. Now, if any of you have been over to the guardrail here, as flimsy as it may look, it's only about 50 feet down to the ground. Only. So Ben volunteered to hang over the edge with rappelling gear and rappel down the side of the building in order to fasten the cable down the side of the building. So he rappelled down the side with a hammer drill and put the anchors in and screwed everything up thoroughly. And then when we went down to put the ground rods in, we had an 8-foot long ground rod and we hit solid concrete, which reminds me we need 2 more of those clamps.
Okay. So
The big brass one.
Yeah, so what we did was we pounded on that thing forever and we hit solid rock at about a meter. So what we did is we cut the 8-foot ground rod into 3 separate pieces, pounded them in a series in the ground with the hopes that if lightning did strike this, electricity would go down through that big thick wire down the side of the building and then run across these 3 short little ground rods that are driven in the ground in a row at the pathway down there. So you make do where you can. And this green wire here is what grounds all these panels together. And what am I missing? Basically all that we did leads up to this masterpiece of electronic circuitry.
Carlos and
Gracias a Carlos.
Michael.
And Michael. Worked all day with Carlos, 2 days, wiring this. Now Carlos is going to explicar la sistema de voltaje, along with Mikey's help. He's going to translate. And I'd like to thank everybody who I harassed mercilessly throughout this whole project. I know they think I'm a pain in the ass, but really my only goal was to make sure that this was done right, expedient, safe, nobody got hurt, and we got it done within the time limit, which was an impossibility based on our first experiences up here. But you guys did great. You guys were fabulous. I can't say enough. I can apologize again, but that becomes redundant. Thanks for putting up with me, and thanks for just pounding at it until it was done.
Yeah.
Look at it.
Yeah.
So Carlos, and Miguel, the electrical engineers of the project.
Prácticamente lo que hicimos estuvo Andrés también con nosotros.
Andrés was with us as well.
Andres, who's not here.
Empezamos a montar las partes electrónicas,
We started with mounting the electric parts,
como el combinador,
the combiner,
el cargador, el controlador,
charger, controller,
el desconectador
disconnect,
y el inversor.
and the inverter.
Bueno, estuvimos montando uno por uno
We were doing it one at a time.
y luego hicimos esto.
And then we did the battery mounting.
Desarmamos la base donde venían los paneles y
We took apart the base that came with the panels, and then we just cut it down, reassembled it.
Luego, pues, a cablear, ¿no? Según el diseño como estaba ya pensado en hacer, en poder combinar.
We tried to follow the design.
Okay. El voltaje de los paneles está tiene que ser 48 voltios.
The voltage of the panels needed to be 48 volts.
Okay. Para entrar al controlador.
To come into the controller.
Ahora el controlador va a cargar las baterías a 24 voltios.
Now it's going to charge the batteries to 24 volts.
Porque su entrada de voltaje es entre 20 a 30 voltios en corriente directa.
Because the inverter only goes from 20 to 30 volts.
Anteriormente habíamos pensado con Charlie las baterías en 48 voltios, porque si fallaba una no iba a afectar, pero podría mantenerse el sistema funcionando.
The batteries were... Mom,
Originally they were going to be 48 volts, but so that if one battery went out, they'd still be able to keep the voltage at the level needed. Pero no hicieron así.
No, ahora tenemos que cambiarlo.
Oh, now they're going
we have to change it.
Ahora es 48 y vamos a hacer un cambio en cables acá en las baterías y pasarlo a 24.
So change it to 24 volts.
Entonces, como salida, pues vamos a tener 110 voltios
We're going to get 110 volts out
para un máximo de consumir de 30 amperios, que es suficiente.
to get a maximum amperage of about 30, which is...
Podría usarse más incluso en otras partes de acá del
You can use it in more
edificio.
parts.
Y pues bien, es un poco así explicado.
We need to get more parts once I get.
No.
I'm not sure, did we get all the
No.
parts yet?
What we need is 2 grounding lugs for downstairs, and we are going to rearrange the cables. It's like a shell game. You can take the batteries and add them together in different configurations
Different multiples of 6.
to come up with different voltages, you know, because there's 6 volts, and so if we want 24 volts instead of 48, we just divide it in half and we have 2 banks of 24. 6, 12, 18, 24. 6, 12, 18, 24. Right now we've got them all in one big loop to make 48. We made the mistaken assumption that since the panels are 48 volts, the solar charge controller is 48 volts, we had 8 6-volt batteries, 48 volts, and when we got to the very end, we discovered the inverter was like 24 volts. So maybe the next biggest inverter would have been 48 volts, but so we have to do a little rearranging. But no, after that, it's ready to go.
Rock and roll.
Pretty much.
Cool. Well, congratulations. Have we heard the story of putting things together?
Well, I mean, have you heard the good parts?
Was Carlos done?
Carlos, I think, is done.
Okay.
¿Hay más que decir, Carlos?
Lo último sería lo que está colocado en la parte de abajo, el switch de transferencia.
He says the only thing left to do is to
Transfer switch.
hit the transfer switch downstairs.
Para que el sistema de red eléctrica con el panel fotovoltaico nunca crucen, o sea, nunca se junten.
So that the
Carlos from the school here needs to actually get trained on this. He's going to come in today, I think.
Yes.
Eso nunca va. Simplemente van a estar aparte. O es sistema fotovoltaico o es sistema de red eléctrica.
so basically
Yeah.
it changes between the grid and the solar array,
Right.
so that they don't cross.
Yeah, it's this gigantic Frankenstein switch. It's like up, solar, down, grid.
Unfortunately, all the computers are on UPSs, so that they don't go off while you're doing this.
Yeah, the
Actually-
computers don't go off.
Well, yeah,
right?
For now.
actually, yeah, we're going to have to work on that because one of the reasons for doing this was hopefully get them off their uninterrupted power supplies. But
We can rig the system as a UPS as well.
yeah, I just have to think about. I mean, we'll have to see how they use it first. Because if they really if they switch back and forth a lot, they'll have to keep the uninterrupted power supplies.
Yeah, and but you can rig this inverter up to function as one giant UPS for that. It's running on batteries and solar during the day.
Yeah.
And, it's still more involved and complicated.
Good.
Doable.
More involved and complicated. Phase 2, yes. Okay. So this is this project.